Is the spring compressed though?
Yeah.
Yeah.
It says
Shows
that
it.
maximum compression.
Like right
You told
here.
us kinetic energy is equal to 0, which means velocity must equal to 0.
Yeah, but that doesn't mean that there's not a force on it.
But it's still,
Oh.
yeah.
But
From the next
since it's
thing,
at
so
rest, the forces are balanced.
Yeah,
therefore it's
sorry,
at
that's,
rest.
yeah, that's what I was getting at.
Okay, so that's a really interesting point. You can be at rest and still be accelerating. Okay, I'm gonna throw this ball up.
I feel like we've talked about that.
Yeah, we
Yeah.
have.
I'm gonna throw this ball up, watch close.
Yeah.
What's the speed at the top?
Oh, but it's still has a negative 10.
But the forces are still unbalanced. So there are moments,
It's just at that given moment.
there are moments
Whoa, whoa,
that.
whoa, whoa.
Woo! Oh!
Almost
Almost got the
So it's
toes.
a toe and a finger all in 1 week.
Because I got like 10, don't worry about it. There are moments where you can be at rest but still be accelerating. We actually had a problem in here. There was a spring and block problem where you push the block on the spring and let it go, and it said, what is the acceleration of the block at that moment, right? But you let it go from rest, it was still being pushed out a ton by the spring. So I think in this problem, all right, the 3M block is on its right, but those two things are at rest relative to one another, so I don't think the 3M block is pushing at all. So I think the force is to the right. Because the spring is compressed, and a compressed spring will push to the right. Now, I'm just trying to reason it out, man.
Intuition.
Okay? Make a decision to move on with your life. If you try, right, or I should say that not if you're trying, if your brain tries to get you to not move on until you feel confident in your answer, you will only answer the first one. Like the 1 out of 3 of these. Don't do that.
You want to try to get as many points as you can.
Get to the first part of each of those, because you can get some easy points in the beginning. Sometimes there's harder points at the end. So if you only do like A, B, and C, but you do A, B, and C of all 3, you're better off than trying to make sure you finish one.
A, B, C, D, F, G, yeah.
Because probably the other one's wrong anyways, let's be honest.
I mean, maybe, right? And you are not trying, like, there's no, like, extra points for getting one whole thing right. It's still only 15 points.
Yeah.
Or you could get like a 7, 7, and 8.
Yeah, I mean, if you had 7, 7, and 8,
That's like a 5.
that'd be pretty good.
Wait, yeah, what's it out of?
It's out of 45,
Okay. Oh, 15 for each one, yeah.
right? So it's out of 45.
How many multiple
Do you
choice
need
are
to
there?
get just over half to get
5?
Usually about 2/3,
What
really.
these
Oh,
are
no, wow, that's.
So like a 30.
That's
Alright.
from
Which Stefan correctly describes the magnitude of the net force on the 2 blocks when the spring is at its maximum compression? Oh, that's a great question.
Okay.
So if you look at this, okay, is the spring pushing on the 2M block?
yes.
Okay? It absolutely is. But if the spring is pushing on the 2, does that mean the 2 is pushing on the 3?
Yes.
It is, right?
Which means 3 is pushing on 2 though.
It is pushing back, but with less force because the blocks are accelerating to the right together.
And there's no friction.
So the magnitude's to the right.
So the magnitude of the net force is definitely to the right, which
So
is
it's
okay.
greater.
But the
on
magnitude of the
block.
net force, is it greater? The magnitude of the net force is greater on block 2. The magnitude of the net force is greater on block 3. So I think this is hard because they've got to try to interpret what they're asking. What's going to be true about the acceleration of each block? To the right. They're to the right. Are they accelerating the same?
Yes.
They have to be because they're still connected, right? If the 3 was accelerating more, then they would separate, and that doesn't make any sense. And the 2 couldn't be accelerating more, because if it was, it would just be pushing the 3 harder,
Yeah, which would then be?
right? So they have to have the same acceleration. But which one has more mass?
3.
So which one has more acceleration?
2.
2.
The 2, if it has less mass, it has...
Yeah.
Oh, I'm sorry. No. You answered my question, but that's not what I said. The acceleration is the same.
Which has more force.
Yeah, that was what I meant. So the 2, they have the same acceleration. The 2 has less mass, therefore the net force on it is
Very-
less.
Oh, I'm sorry.
To keep the same.
Because the ratio has to be the same.
Oh, it's ratios, not multiplication.
The less, so more
Oh, this is a hard question. Yes, the answer is no. But we haven't gotten there yet.
Wait, what was the one for
We
two?
know the answer now.
The magnitude of the net force on each block has the same, no. The magnitude of the net force is greater on the block mass 2, no. Because it has less mass, it needs less force. Okay, so I think it's this one. Now again, I'm guessing, and we're moving on with our lives.
I like that one.
Good guess.
Okay? Yeah.
For that one before it, did you say how you justified your answer for that?
Yes, I would say, it says in which direction is the net force? I would say, looking at the 2m block, we know it's accelerating to the right because the spring is pushing it to the right. Therefore, since it's accelerating to the right, the net force is to the right.
So,
We could look. You guys want to look at the answer?
Yeah, I was just like, I understood it, I just didn't know how you explained.
can you
it.
explain? For these problems like this, like F, is it 1 point for the right answer and 1 point for the justification?
You know what? It always depends.
Okay.
Well, what counts as a justification? Do you need to show math, or do you need to use words to describe
Oh, look at
the question?
Did we get it wrong?
So, look how fun that is.
They made them the same size.
Yeah, so it's all right. Life goes on.
My whole life is long.
We got this one, we nailed it. So this one was 2 points, one for each force diagram. Here, for an expression of the conservation of momentum, and a nice answer. See, 1 point.
I think it's best to just not.
Oh, we really, oh wait, no, never mind.
Their scoring is so whack, it's like, 1,000 points for your name. And
So, so for a correct expression of the conservation of energy, that looks pretty good. For attempting to integrate, nice job. For using the correct limits, 0 to d, there's a point. And then for a correct answer, there's a point.
So we didn't.
Does, in the AP style test, does it always start easy and get harder as each, in like physics case?
So that's within a question and over questions.
Oh, both ways.
So like, in this case, it would probably be good if like, you have to divide and conquer, it'd always be good to try the first couple of each and then move on, try the first
I
couple,
think so.
move on, try the first couple, and then if you have time.
Yeah,
go
except
back.
there's force diagrams, man, or it's a collision, you just write down the conservation momentum
That's
formula.
an easy,
That's a point.
that's an easy 6 points right there, just
Right.
looking by the force diagram.
Um,
And then you get 3 out of
Now,
45.
I know that there's some of you, okay, there's some of you don't do calculus well, and that's totally fine. You may get to this and be like, nope,
Skip.
just move on with your life, man. If it's gonna take you more time to try to figure this out,
Then the entire question.
and you can read this one real quick, because you don't actually need any information from here to look at this one.
Right, you do need information from some of the other ones.
Yeah, so
Sometimes.
like, if there's any of these check ones, these are good, you can easily just
So,
guess.
Michael, here's what it
Yeah, you
says.
get the point, if you just get lucky.
For selecting the correct answer right with a reasonable attempt at justification, you get 1 point. An example says, at maximum compression, the 2-block system is instantaneously at rest. The only horizontal external force acting on the system is the spring. This force is directed to the right. The system is therefore accelerating to the right because the net force is to the right.
Well, it's pretty simple.
Says as he stares at the answer.
Well, but here's the thing, it's like, you could have come up with that on your own. Maybe not the way that they said it, but like, you're like, yeah, if net force is to the right, acceleration is to the right.
But didn't he not justify what the question was asking as it compares to the
That was
mass of the
E.
3M? Oh, oh shit.
The magnitude of the net force is greater on block mass 3.
Yeah.
Because the blocks stick together, they have the same acceleration. Because it has more mass, the net force must be greater,
Yeah,
right? There was F, I missed F completely.
that was the one where you
You meant
just
to
checked
check, I was
out.
like,
that's
no,
hard.
moving on.
You
Oh,
stay
yeah,
away from my slippers.
Not simple harmonic motion. But you don't know what that is yet. Wait till next week.
No, I was about to ask that.
Exhibit simple harmonic motion.
Wait till next week.
I feel like nothing. The word
Nothing is
simple
simple.
Yeah.
It's a harmonic series, right?
Oh,
Well,
yeah.
Stop.
So a simple harmonic
Yeah,
oscillator,
just-
okay? A simple harmonic motion is when the restoring force is linear with the displacement. Okay? So like if you put a block on a spring, Hooke's law says that the displacement is linear with the restoring force. That's the spring pulling it back. Right? But this is the nonlinear spring.
So it's just, are all linear springs?
The bottom.
Yeah, I mean, that's the thing.
Okay.